All right, welcome back to Advanced Functions 12. So in this lesson now, we're going to be shifting our attention to two important concepts in advanced functions, which are going to be the slopes of the secants, which is going to be this lesson, and the average rate of change. And in the next lesson, we're also going to be having a look at slopes of instantaneous, slope of tangents, and the instantaneous rates of change. So the next two lessons are going to be quite short compared to what we had to look at with the 4 lessons. Um, so yeah, let's get started. So first of all, in previous years, we had to look at the slopes of a line and how they would represent the rate of change between x and y. For example, if we had to look at the equation of a line, how do we determine the slope? Well, for example, if we we're given 2 points, pick 2 points here, take this point, and we would basically calculate the slope between them. So if this was x2, y2, the first one was x1, y1, then we would calculate the slope between that. And how do we use that? The slope formula we should be familiar with, which is simply just given by y2 minus y1. So we're taking the distance between each of the y values, and we're also going to be dividing it by the change in y, the distance, the distance between the x values, which is also going to be the same as saying the change in y. So we put delta y over delta x, which represents the average rate of change. So for the first definition that we'll have a look at, a secant line is a secant is basically like a line that connects 2 points on a curve. So now we sort of had to look at linear lines, but how the slopes can be found from linear lines. But how can we actually determine from a curve, let's say that it's not a linear line, how do we determine the slope and what it would represent? So the average rate of change between 2 points corresponds to the slope of the secant between 2 points. So let's say we have the plot that is given below, and we pick 2 points from it. So let's just say that we pick, let's say this point over here. Let's call it point A, which is going to be corresponding to x1, y1. And then we take a point, let's say over here. Call this B. And this is called x2, y2. So that means the slope of the secant line, by definition, it connects 2 points on a curve. So that means if we connect A and B together like this, let me try to connect them together. That is your secant line. So this blue line over here is a secant line. Or this is your secant. So this determines the average rate of change between the 2 points A and B. So if we want to determine the average rate of change of the curve, how do we do that? So we could say that the average rate of change here is simply just going to be the change of y. So what is going to be the change of y here? So that's going to be your delta y. So what's going to be changing every time we move across the graph from left to right? And then we also have to look at the change in x. So what happens between the x values as well. So that's going to be your delta x, which is exactly what we had to look at with the slope formula as above. So that is simply just going to be delta y over delta x, which is basically taking the difference between the two y coordinates and taking the difference between the two x coordinates, x2 minus x1, like that. Which is also, as we would say, it's a change in y, and it's also a change in x. So there are 3 specific cases that we would have to pay attention to whenever we are interpreting the slopes of the secants. So let's have a look at each of the cases. So let's say what happens when the average is greater than 0. So if the average is greater than 0, meaning that the slope is going to be positive. Slope is positive. Then this implies that there's going to be an average increase. Then it's going to have an average increase from A to B. And similarly, if we say that average is less than 0, that means the slope is going to be negative, which means it's going to be an average decrease instead. And last case is when what happens when the average is 0. So let's say if the average was equal to 0 instead, then the slope is, which means that the slope is constant. It does not change. So that means the average stays the same from A to B. So those are the 3 specific cases that we would have to pay attention to. So like the first case is what happens when the average is greater than 0. So that means the slope is going to be positive. And it's also implying that it's going to have an increase, average increase from A to B, because the slope is positive. And the other case is when the average is less than 0, which means the slope is going to be negative. That means it's going to be an average decrease from A to B. And last one, when the average is greater than 0, then the slope is constant. So that means the average stays the same. So it does not change. So there are applications in which we would use the slope of secants. For example, if we take a look in physics, if we have a look at the distance time graph, for example, we would use it to determine the average speed of a particle moving from A to B. So let's say that the particle is moving from A to B, so it's going to go here all the way around to B. And we want to determine what is the average speed between A and B. This is the time when we would use an secant to determine the average speed. So, and sometimes in chemistry as well, we would use the secant line to determine the average volume change as temperature changes as well. So we will explore some of these examples in today's lesson as well. Okay, so let's have a look at the first example. So let's say that we're given the graph between x and y, and we want to determine the slope of the secant of the following. So the first thing that we want to have a look at is the slope between A and B. So just a quick point out here. A here is going to be the origin point. B is going to be the point 26. C is going to be the point 56. And then D is going to be 9, 2. And we want to determine the slope between slope of secant between each of these points. So from A to B, so let's just say that the average, and then I'll put A comma B to represent the final and the initial and the final point. And basically we take the slope formula, slope of secant formula, and we just calculate the average. So that is simply just going to be 6 minus 0. So B is going to be the x2, y2 here. And x1, x2, or x1, y1 for the 8.8. So that means x2 minus x1 is going to be 2 minus 0, which, if we calculate the slope, would give us an average of 3. So that means because the slope is positive, that means the curve this red curve, is going to be increasing. It's going to have an average increase of 3 between A and B. Now let's calculate between B and C now. So the average from B to C is basically calculating using the same formula. We're going to call C x3 y3. So that is simply just going to be y3 minus y2 over x3 minus x2. So putting the values in, we have 6 minus 6 divided by 5 minus 2. And the result that you would get is 0, which makes sense because here you would see that we have a constant slope. So we have a slope of 0, meaning that the average does not change. It's still going to stay 6. And it does not change, it does not go up, or it does not go down between B and C. So we would conclude that the slope is constant and the average does not change between B and C. And then the last one for C here, between C and D. So we have the average of C to D. So we're going to call this x4, y4. And we have the following. So same thing, we're going to take the final point, which is 2, and the initial point, which is 6. And then we take 9 minus 5, which is just going to be negative 1. So that means it's this between C and D, the curve is going to be decreasing on average by 1 unit. So those are the 3 cases that we had to look at. So first case where we had to look at an increasing slope or average increase, so meaning slope is positive. The second case where we had to look at a constant slope, which means that the average does not change. And then the last part from C to D, what happens when the slope decreases, which means the average is decreasing, but the slope is negative. All right, so another example that we could have a look at is the following. So let's say that a ball was thrown into the air such that the height h in meters and after t seconds can be modeled by the function h of t is equal to negative 4.9 t squared plus 14t plus 1. So let's determine the average rate of change of the height of the ball for each interval. So how we would do this is we would calculate each of these endpoints. So we want to calculate h of 0, and we also want to calculate h of 0.5. So let's see. So if we put negative 4.9 times 0 squared plus 14 times 0 and then plus 1, this is just going to equal to 1. And then similarly for 0.5, we would say 4.9 times 0.5 squared plus 14 times 0.5 plus 1. This value is going to give you approximately 7.775. And then to calculate the average rate of change, we simply use the slope formula. So we would say that the average between the time interval 0 to 0.5 is given by, so the final point, which is 7.775 minus 1 divided by the 2 times, so between 0.5 and 0. This value, you would get 11.55. And in part B, we will use it to interpret our results. So we'll save that later. And then now let's calculate what happens between t is 2 and t is 2.5. So using the same method, we would put 2.5 or 2 and 2.5 into each of these t's. So now let's just say that we put them in automatically, and we would get a result that would be 9.4 for h of 2, and then 5.375 for 2.5. So that means the average between 2 and 2.5 is simply just going to be 5.375 minus 9.4 divided by the 2 times, which is 2.5 minus 2. You would get an average of negative 8.05. So those are the two slopes that we have. Now let's try to interpret it in part B. So let's say we want to explain why do you think that we would get a positive slope, and why would it make sense that it would be a negative slope here? Or basically, what does the positive slope represent, and what the negative slope represents? So that means for part I here, we would, since we have a positive slope of 11.55, that means the height of the ball is increasing on average by 11.55 meters per second from 0. T is between 0 and 0.5. And similarly for the second one, we would say that the height of the ball is decreasing on average by 8.05. So we would say it as the absolute value one instead. From T is between 0 and, no, not 0, 2 and 2.5. So that's how we would interpret what it means to have a positive slope and what it would mean to have a negative slope and what it means. So with that, let's have a look at another example. So now this is involving some business applications where we can have the amount that can be modeled using the table that is given below. So let's just say that we have some money in the bank account. So initially we would have $5,000 and then it would just be increasing on, let's say. So suppose t equal to 0 be the year 2015. So that means we would be saying year 0, 1, 2, 3, 4, 5, and 6. So let's determine the average rate of change of the amount in 2015 to 2018. So let's just say the average, so between the time interval, so 2015 would be 0, and then 2018 would be year 3. So we would determine the average rate of change of that. So we just pick the values out of the table. So for 2018, we 5,578. T0, we would have 5,000. And this is divided by 3 subtract 0. And that would give you an amount of 192.67. And similarly for part B, we want to determine the average from 2018. So that's going to be year 3. And 2021 is going to be year 6. So we just pick the values again. So we take 6,700, subtract 5,578, divided by 6 minus 3, which would give you an average of $374 here. So those are the two average rates. So let's try to interpret the results from A and B. So part A, we would say that the amount of money, so the amount of money in account is increasing on average by $192.67 between 2015 and 2018. And in part B, we would say that the amount is also increasing. In account is increasing on average by $374 between, I should say per year as well, 2018 to 2021. So that's how we would basically interpret our results for both parts A and B. So as mentioned, this is going to be a very short lesson. Well, this lesson and the next lesson as well. So basically, we just simply had to look at the definition of the secant, which represents a line that connects 2 points on a curve. So the red line would be like the curve, and we would take 2 points and calculate the average rate of change, which is just using the slope formula that we are all familiar with. And then we had to look at what the average would mean if it's positive, negative, or a constant. And we have a look at the 3 examples where each of these represent like what how we should be familiar with the averages and the slopes being positive, negative, and constant. Then we had to look at some applications, one involving the height of a ball, and how to interpret the results, and one financial application that involves money and how it can be modeled using a table of values. So that is all for today's lesson. So if you have any questions, just feel free to let me know, and I will see you guys in the next lesson.